Okay, this video should be after you watching slope video and the coordinate system video. So let me write down for you. You need to watch slope video and the coordinate system. Then keep going. We have this new video. We talk about linear equations. Now, when you see linear equations, don't assume it's talking about a line, okay? It's not only talking about a line. Linear equation means if you have 3 dimensions, if you have 2 dimensions, then yes, you have only x and y. But if you have 3 dimensions, then you have x, y, z, for example, okay? Now, linear equation, their x, y, z will be at most first degree. For example, 3x plus 5y equal to 7. So 7 means 0 degree. Okay, if you have 3 dimensions, 2x, 3y, 7z, at most 1 degree, then we call this as a linear equation. If you have x squared plus 5 equal to 1, then the second degree, then we don't call this as a linear equation. Then this is not linear. So that's one thing I want to remind you. And then keep going. Oh, let me see how come my screen. Okay. And then keep going. We have to talk about the geometry. From the geometry and from last video, we talk about you need a 2 point to decide a line, means 2 givens. So after you watch the slope video, I have a proof for the formula for the equations. So let me show you here. So we did prove the formula for a equation of the line y equals to mx plus b, or another formula. Okay, so if you have a slope and the y-intercept, so 1 point and the 1 slope, right? But this point happen to be the y-intercept. Y-intercept means x equal to 0. Then another situation is if you have a slope and the 1 point we call CD. There's also 1 point and a slope. So we call this point slope form. And this one we call slope intercept. So on the slope video, I prove this formula for you, and on today's formula, I emphasize that you need 2 givens to decide the equation. So how about if I had 2 points, AB and CD without slope? How you use these 2 formula? Very easy. We have a slope formula. You find the slope with these 2 points. So you can have always y on top, x on the bottom. Okay, the change your y over change your x. Rise over run. So d minus b, x minus x. You find the slope. After you find the slope, you can choose either 1 point. you only need 1 point for either formula. Okay? If you have y-intercept, then you choose y-intercept. If you have no y-intercept, then you choose either point and then use formula 2. So the proof of the formula, very easy. I already did on slope video. And for any equation of the line, first you need a general point called xy. So on the line, how many points on the line? Many points. The given only 1 point, right? And a slope, or at the most give you another point. So you have at the most 2 points. I won't give you all the points. So many points, how can I give you all the points? But so many points, they have a general name called xy. Okay, so every 1 point called xy. So the relationship between x and y, we want to find the relationship between x and y, then it will be the formula. So the relationship between x and y is x and y, and make it equal. And we use given to make the relationship between x and y. So this is a little review from last 2 videos. Now, starting from today, I want to show you something interesting. Is we have so many different types of the straight line. This, right? And today we want to emphasize 2 types of the lines. And these 2 types of lines, why are they special? Because we do not need a formula to find their equations. We may use concepts to find their equations. Then that's interesting, right? So what's these 2 lines? They are vertical lines and the horizontal lines. When you are talking about vertical lines, means upright like a building. Or horizontal lines like a floor. If you have a whole floor, the line is horizontal. Obviously, the slope is 0, no doubt. But how about a building? What's the slope for a building? That's what we want to emphasize and learn for today. Okay. So number 1, on the numerical line, if you have a x equals to 5, just 1 dimension. If you have 1 dimension numerical line, you say x equals to 5. Then it means 1 point. No y. No y. Okay? So it means x need to be 5. That's given. So that's the first situation when you have 1 dimension. However, when you have 2 dimensions, so on the xy plane, or we say on the coordinate system plane, I may talking about x equals to 5. Or I may talk about y equal to 5. On xy plane, x equal to 5 is not 1 point. It's a line. Okay, so this is a line. Also, y equals to 5 is another line. That's what I want to emphasize for today. Okay, they both a line. with infinite many points on the line. Why? Okay. So on the xy plane, go back to the one dimension. When they say x equals to 5, then they define x need to be 5, no other choice, no other possible. So x need to be 5, no other choice, no other possible. Now on the xy plane, when it says x need to be 5, x equals to 5, that means no other choice, x need to be 5. But did they say what's y? Did they talk about y equal to something? They didn't. So that's interesting. Okay, when x equals to 5, let's draw x equals to 5. X equals to 5 is here. And did they say what's y? They didn't say. So y can be any number. Y can be 1, but x need to be 5. So you can have 5, 0. You may have 5, 1. You may have 5, 2. Or 5, whatever the number here. Any possible y value. Okay? Any possible y value. So in this case, you have this one, x equals to 5. You own a building. X equals to 5. Okay. Now, when you talk about y equals to 5, means y need to be 5, no other choice. But how about x? Means x can be any number, not restricted by the given. So x equals to 5, y equals to 5, right? This one. Y equals to 5 is here. So y equals to 5. Y need to be 5. And y, x can be 1, x can be 0, x can be -2, but y need to be always 5. Y can be, x can be any number here, but y need to be always 1. So what do we have? We have a floor on the level 5. Make sense? So using the concept, when you have y equals to 5, that's an equation of a horizontal line. Here. Okay. And if you have a x equal to 5, then x equals to 5 is also an equation. X equals 5 is also equation of a vertical line. Okay. So right now we are talking about the idea of horizontal line and the vertical line. Now let me erase those marks. So first, when y equals to 5, so that's a green color. When y equals to 5 only, but s can be any real number, then you have a horizontal line. So means slope equals to 0. This one is no problem. If we keep going, if you have x equals to 5, so we have a vertical line. We talked about that earlier. Then the problem is easy. You say x equals to 5 and you just learn this is the equation of the line, a horizontal line, a vertical line. the vertical line. Now I want to ask you, what's the slope? We understand the horizontal line here, right? Let me change the color. The horizontal line have slope equal to 0 because it's horizontal, slope equal to 0. And the vertical line, what's the slope? Okay, so that's what we want to learn for today. How do we describe the slope for the vertical line? Undefined, positive infinity, or negative infinity. Why I say infinity? And if you watch the video for the slope, we talk about if you have a slope, this direction is a positive slope. If you have slope this direction, we say it's a negative slope. Now the value of the slope, I say absolute value of the slope without positive negative. When the slope close to a building, close to vertical line, when the slope close to 90 degrees a building, the value of the slope, so this will be negative more and more and more. This will be positive more and more and more. Okay, so from slope 0 horizontal line, you have more degree, more degree, more degree. Means slope is bigger and bigger. You have bigger slope number. Here, biggest, very big. How do you know it's very big? Let me show you mathematically. I calculate for you, okay? Let me erase this. So remember, the slope, we use rise over run, right? Rise over run. Slope equal to rise over run. Means the change of y over change of x. So, for example, if you have a slope around here, so this is change of y, this is change of x. Okay. Now, when you have a bigger slope, do you see the y is bigger over the same change of x, right? And then when you make it bigger, let me see if I have space. A bigger, you have bigger y, right? You have bigger y. So this y become bigger and bigger and bigger. Okay. Now here, I will say that's the biggest. Very big. How big? We try to not change x But if you don't change x, you can never reach here. So let me have other type of the graph to show you, okay? So another way to show you the graph is you have this, right? If you follow the circle, okay? Make it bigger and bigger, and when you make a bigger and bigger slope, the x becomes smaller and smaller. So y value becomes bigger and bigger. So let me change the color so you can see better. Okay. So originally we have a normal triangle on the unit circle here, on the circle here. Okay. But when you go closer to 90 degrees, you almost cannot make a circle, or you almost cannot make a triangle. If you want to go closer here, you can see these two green lines merge together. If you want goes to blue, okay, green want to become blue. These two lines, the triangle no longer form a triangle. It smash together, become one line, and the delta x become 0. Okay, so it's something to do with delta y over delta x. The slope is delta y over 0. Okay. Now from the other side, you have the same idea. Your triangle, when you want to close to 90 degrees, this triangle need to be smashed together, become 90-degree line. So delta x becomes 0, and the delta y is some number. Okay. So again, if you approach your slope from left hand side, that's a negative slope. If you approach from right hand side, left hand side, that's from right. Then you have positive slope, and from left hand side you have negative slope. Now the problem is when you have denominator equal to 0, like 5 over 0, 7 over 0, usually we say undefined. Undefined, that's when you are young. You are on the pre-algebra or basic math. We say it's undefined. But undefined, I can tell you, positive undefined is very big. And the negative undefined is very small. Why is very small? Because negative big. Negative very big means very small. Okay, so I have some calculation want to show you the idea. If you have 12 divided by 12, answer is 1. When you divide by a smaller number, so let me show you. If you divide by a smaller number, then your result, after you divide, the result become bigger. So divide by 4, you have 3. So 12, 6, 4, 12, 6, oh, change the color, sorry. When you divide by a smaller and how come I would like to change it to blue? Sorry, let me change it again. Okay. When I divide by the number smaller and the smaller and the smaller and the smaller, what happened? The result is bigger and the bigger and the bigger and the bigger and the bigger. So if I keep dividing the number to smaller number, smaller, 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 my result supposed to be bigger and the bigger and the bigger and the bigger and the bigger. So you can calculate by yourself. That's very big. If you divide by a very small number. Okay. So in the end, I want to tell you, if you have a big number divided by a very small, almost zero, what do you have? You have a very big, we say infinity. Okay? So if this is positive, then we say positive. Slope is positive, very big, infinite. And if you have a negative slope, then you have a negative, very big number. So that's how I tell you the idea. Undefined either means very big or very small, or you say negative very big. This is positive very big. Okay? Keep going. We want to talk about two parallel lines. If you have two parallel lines, they have same slope, but different y-intercept. Parallel means these two lines don't touch each other, no intersect. Okay? So if they don't touch each other, they need to have same slope, but different y-intercept. If they have same slope and the same y-intercept, means these two lines are the same line. Okay? Now from here, why they have same slope? If these two lines, if you learn geometry before, then we say if you have two parallel lines, you have if you cut a line, they have same angle. Okay. If they have a triangle here, they have same ratio. Let me erase this. Sorry, we don't supposed to talk about geometry here. But anyway, from this example, I want to show you rise over run is the slope. So slope 1 and the slope 2, they have same thing. Rise over run. Rise over run. Okay. Or you can say rise over run. So M1, M2, they have same slope if they are parallel. Now this is kind of easy, and then we keep going to the end. We are going to talk about how about two perpendicular lines? Do they have same slope? No, they don't have same slope, but their slope multiplied together equals to -1. And let me explain why. It's a little hard, but I think it's understandable. Okay, from these two pictures. This case is when you had two lines, let's say line 1 and the line 2. This line 1 and line 2, their y-intercept at 0, means they intersect at 0, 0, origin. Okay? In this case, you can obviously see if they are 90 degrees, these two lines, we say line 1 perpendicular to line 2. Perpendicular means these two lines form a 90 degree. Then, when you calculate their slope, slope 1 will be rise over run, b over a. And because our coordinate system is 90 degree, right? So when you rotate this line 90 degree, you have line 2. Because line 1, line 2 are perpendicular to each other, or when you rotate the x-axis to y-axis, then you kind of merge line 1 and the line 2 together. So in this case, you can find this is negative b and this is a. So slope 2, you have negative b over a. And calculate them together, m1 minus m2, b over a multiplied negative a over b. So they are reciprocal. Reciprocal. So, but the negative reciprocal, opposite. Opposite reciprocal. So cancel out, you have negative 1. Okay? Now if I move their intersect from origin to somewhere else, you still have two lines, line 1 and the line 2. And their slope is still the same. You just move their intersect. You didn't change the line, right? You changed the line to somewhere else, but you didn't change the slope. So still slope 1, still slope 2. Just the intercept change. For example, if we have line 1 is y equals to, if this line 1, okay, let me erase something to make some space for me to write down. Okay, erase and change the color. Okay, so line 1, you can say is y equals to m1 plus 0, because y-intercept is 0. Line 2 is y equals to m2 plus 0. Okay, and then when you move the same these two lines, but change it to a new intersect location here. Now they may have different y-intercept. So let me change color. So this one say intercept, for example, is 6. And so this is 9, 2. 9, 2 will be y equals to m2, same slope, okay? X, oh sorry, I forgot to write down x. Oops. To x, okay. So y equals to m2x plus 0. And then line 1 equation is y equals to m1x plus 0, because the y-intercept is 0. Now when you go to this picture, when the y-intercept is not 0, now according to this picture, y equals to m2x plus 6. And when we go to 9, 1, it looks like the y-intercept is about 2. Okay, about. So y equals to m1x plus 2. So, but they still keep the same slope. Okay. Therefore, even though you have 2, 9 and the y-intercept, and this 2, 9 not intersect at origin, or in other words, the y-intercept not 0. Okay, you still have the same property for the two perpendicular lines. Their slope multiplied together is -1, or slope 1 and the slope 2. They are not a positive one. Sorry, not a positive reciprocal, is what? Negative reciprocal. Okay, slope 1 and the slope 2, they are negative reciprocal. In other words, slope 1 multiplied slope 2 equals to -1, not a positive. I said something wrong earlier. Okay, it's negative, not a positive, because equals to -1. Okay, so I'm end with this extra video to talking about the horizontal line, vertical line, and the parallel line, and the perpendicular line. Okay, so see you next time. Bye bye.